Hello YouTubers, today I'm going to take a little bit of time to explain how to create a jump lead in order to discharge filter caps. I've seen a lot of questions online, forums, and even videos explaining how to discharge your filter caps, but not a lot of information on how to actually build them. So I've decided to take a little bit of time today and show you how quick and easy it is, and I definitely suggest that if you do not know what you're doing and you're trying to discharge filter caps, ask somebody that does know what they're doing, because it's not worth your life. Okay, so I've got my little workstation set up here. I've got my soldering iron. That's my stand where I'm going to be actually applying the, or rather not applying, but setting up my camera so that you can see when working, or when I am actually working. So here we've got two different types of cables. We've got one standard alligator cable or alligator clips attached to a jumper cable, and this is not insulated. And when I say that this is not insulated, as you can see, the wire itself is insulated, but the clips are not insulated. So you want to avoid these types of clips. What you want are insulated gator clips, which are these guys right here, which is exactly the same components, same type of lead, same type of clip itself, except it just has a coating all the way around it. And as you see, you push a little bit and they open up. Exact same thing as these guys over here, but they're insulated. So what you're going to need basically is your jumper cable. So this guy here, just wanted to demonstrate what not to use. Throw that away. So what we're going to need is the jumper cable. So we've got that here. You can turn on a little bit of light just so that you can see better what I'm doing here. I don't know how much that's helping, but alright. So yeah, jumper clip, soldering iron. Got something holding down my soldering iron there right now. Just a little bit of weight. But needle nose pliers are always good as well, especially for getting some of your stuff clipped in tightly together. So here what we've got is a 10K 5-watt resistor, and basically 10K 5-watt is just going to drain the caps a little slower. The reason that you want the resistor there is so that you're not actually discharging everything right at the same time, and that's what leads to sparks and loud bangs, pops, crackles, things like that. The energy needs to dissipate, and it will do that through sound or light or through your body. So a resistor is definitely a good thing to have for this. So in essence, what I'm going to be doing is taking this resistor here and putting it into the cable loop itself. So here, let's do this in the light. So what I'm going to end up doing is something like this. I'm going to splice the cable right in the middle there, and I'm going to attach the resistor, solder it all into place. A couple of other things I have here. I've got my solder. This is a decent quality solder. It's always good to use something that's of better quality. You don't want to get something that's really cheap or toxic or that has, a high content of lead. Acid-based is always good. Something with flux as well is always good. That's what I prefer, is the flux-based one. This guy here is only 2.2% flux, which, does it for what I need. I've also got some electrical tape. You can also use shrink wrap, and what this is going to be used for basically is just protecting the resistor and any exposed pieces of wire or metal. I've got my wire clipper here and a stripper, and I've also got a little screwdriver here. And the screwdriver basically is just in case I need to make any type of adjustments to my soldering iron. So we probably won't need that, but anyway, here goes. Okay, so first things first, we're going to clip this guy here. As you can see, I've marked it, a little black mark there, and that's just basically to indicate to me where to cut. I'm a little OCD for that type of stuff. I like to have same length, same size. So here we go with that. Cut the lead in half. So that's done. It's in half. Now we're going to strip the wire. And you only want about a 1/2 inch here to remove. It's more than adequate. So these guys are 18 gauge wires, so they're a little thicker than your 20 or your 22, which is good. A lot of the time they indicate that you should be using a 20 or a 22 gauge wire, and this won't make too much of a difference. So now we've got both of our ends here, as you can see, separated. My soldering iron is heating up. Next, what I'm going to do is I'm going to be trimming these a little bit, just because I don't need all of that length of the wire there. And if you're wondering why this is square in shape, it's because there's an actual resistor inside of there, but it's covered in cement. It just helps it to insulate that much more. So I'm going to cut off some additional ends to this here. And what I'm intending to do afterwards is actually loop it so that I have something to attach those other wires to, the lead wires. So now we've only got a piece like that. So now what I'm going to do is bend those actual pieces inwards to make a loop. Now you want to be careful doing this too, just because you don't want to break anything. Alright, so now what I'm doing is I'm just going to use the needle nose plier to bring it down. Make a little loop, kind of like that, so that I can just put my wire into it, and once it's in it I can crimp it down even more, and that'll make sure that it actually stays in. So let's do the other side. Pull that back a little. That's down and in, perfect. See, that's great. That's exactly what we want. It's a little loop like that. I'm just going to finish this guy up, I might as well, while I'm here. And there we go. So we've got our other little loop on that side. So what we're going to do next is attach the lead to it. And so what we're going to do is attach our lead right through, just like this, kind of like putting a piece of thread through the eye of a needle. And there we go, so we've got that. Now what I'm going to do is I'm going to crimp that end and just twist it a little so that we've got it nice and uniform there, that it's actually holding on its own. But this in itself is not enough. You absolutely need to solder it. I know some people might be thinking, oh yeah, you can just, leave it like that and you've got your connection, but no, I would always definitely tell you to solder anything that you have a connection with or on. So I'm going to crimp that a little more, just to make sure everything is nice and tight there. So that's good. I've got one end. So what I'm going to do is attach the secondary end now. And it really doesn't matter which ends that you're putting on where, because it's not like there's a negative or a positive. All you really need to do is make sure that they are attached properly and correctly. So this way here, what I'm doing is I'm just wrapping it around, just making sure that everything is attached nice and tightly. So there you go, as you can see, that's nice and neat. So next, what I'm going to do is I'm going to be applying the solder. So in order to do that, I have to make a little modification here, and I'll be working over here. So that way you can actually see a little better. Okay, that should be good. So what I'm doing now is I'm preparing my flux, or rather not my flux but my solder. What I like to do is actually loop it through the hole itself, and that basically gives me a little more control over what I'm actually doing, just because I've got a base here, something to work with. So what I'm going to do is I'm going to start by tinning the tip of the actual soldering pencil tool here. And what that does basically is it allows the transition of heat to be a lot easier on the actual surface that I'm working on. So that should be sufficient. Wipe off some of that junk. It's nice and tinned. So now what I'm going to do is I'm going to wipe off the excess. Another thing you want to do after you've tinned the tip is basically to wipe it off. You don't want to keep that junk on there. So that's what I'm going to do. You don't want to hold on to it for long because it's hot. It's very hot. As you can see there, it's nice and shiny. That's what you want. I know some people too have some difficulty with their soldering irons, and they say that it doesn't work well, it doesn't, melt the solder, things like that. Well, what that means is that the tip of your actual solder itself is pretty much dead. And when I say dead, I don't mean that that's the end all of it. What you would need to do basically is use some sanding paper and sand it down just to get some of that crass off of it, because that's what's happening basically, is that you can't transfer the heat properly. So here we go. We're going to start applying the solder. One tip I could give is to always try to heat the actual component that you're trying to add the solder to. You don't want to be adding the solder to, or you don't want to be just melting the solder directly to it. And one of the benefits to this basically is that it gets sucked into the actual component a lot easier if you're heating the component itself, because it's already warm. So that's what we're going to do here. I'm going to start heating this. So just heat that a little bit. About 10 seconds is good. And beautiful. A little bit of extra there, just to make sure. And you see all the smoke that's coming off of that? You do not want to be breathing this in. This is not good for you. So always try to work somewhere that's properly ventilated and avoid breathing this stuff in. Again, there's a lot of junk on the end of this, so I'm just going to wipe that off. And don't hold this for a long time to the actual tool itself, just because it is very hot. So let's inspect our first solder joint there. And that's pretty decent. Everything's nicely covered. The wire itself is soldered. You can see that it's been sucked in there. It's now silver as opposed to copper. So we know that we've got a nice strong connection. So now the next side. Gonna flip that around. Gonna heat this guy a little bit. That should be good. You don't need a ton of solder, but you just want to make sure that it's actually been absorbed properly there. So that should be it for soldering. And again, another word of advice. If you're not using your soldering gun, turn it off. Always turn it off. Better safe than sorry. So now if we take a look at what we've got here, both of the ends are soldered. We've got our clips on both ends there, resistor in the center. And the next step is to cover that center resistor and any exposed metal with some electrical tape. As I said before, you can always use shrink wrap. As a matter of fact, I would prefer shrink wrap. I just don't have any available on hand at the moment. So, I'm going to use some electrical tape right now. What I like to do is start with the center. And watch out as well, the resistor can be hot after applying this solder to it. So always just be careful. Now, as I said before, better safe than sorry. So that's good for that point there. Some scissors would probably be helpful at this point. Now personally I'm going to try to make this as pretty as I can, which isn't saying a whole lot. A secondary piece of electrical tape. Missed a little spot in the middle there. Make sure that you've covered pretty much everything. It's always good to do that. Always better to err on the side of caution. So as you can see here, there's still a little bit of exposed wire. So what I'm going to have to do is continue with some more wire, go around it again. And likewise on this side, I'm just going to try to tighten it up a little more so that it doesn't open. Alright, so I'm starting on this side first. I'll try to continue the covering of the exposed wire. And you want to get it nice and tight down there. I've used an excess amount of tape here, but that's just because I'm a little bit in a hurry to get this done, since I only have a certain amount of time. So there you go. Nothing's exposed. That's what you want. Likewise on the other side, nothing's exposed, but I want to be sure. Shrink wrap does do a better job than tape itself. But if all you have available is the electrical tape, then by all means, it's more than adequate. Another thing I'd like to talk about is the value of the resistors themselves. A lot of people are confused as to what value you need for the actual resistor itself. You can actually figure it out if you use Ohm's law. I'm not going to get into it because it's a lot of science, and I know that you guys aren't probably here to listen to scientific stuff. You just want to know how to build one of these. So, there it is. If you're interested at all in learning how to determine the values, look for Ohm's law. What you're going to want to do is find out how many volts your amp holds, or the capacitor charges, and basically apply your Ohm's law to that. So, thank you very much for watching. Always be safe, especially when working with electricity. You know, it's not worth your life. So, I mean, if you don't know what you're doing, by all means, you know, talk to an amp tech, get in touch with an amp tech, because you don't want to die for something stupid like trying to bias your amp. Alright, so that's about it. Take care, and I hope this has been informative. Ciao.